solve the next problem by simplex method. So maximize p equals to 2x plus 3y plus z subjected to the constraints. So these are the three constraints are given, so we will come across three slack variables. So what happens here, so we have to balance the given constraints, so by using the suitable slack variable. So we are s1, s2 and s3. so this is your new balanced constraint. So let us consider the initial simplex table. How can you consider that? So this row is from the first constraint, first balanced constraint. The second row is from the second constraint, and third row is from the third constraint, right? And of course, while writing the delta row, we have to consider the negation of the coefficients of x, y, z. So 2 is there, we need to write minus 2, and 3 minus 3, and 1 minus 1, like that. Fine. And after that, what we have to do, so we have to identify the smallest negative number in the delta row. So this is minus 3 is the smallest negative, right? And I can say that this is your pivotal column. I want to identify the pivotal row, so that we have what we have to do. So we have to consider the ratio of quantity by the pivotal column elements. So 11 by 3, 19 by 2, 25 by 1. So these are the three ratios. Okay. So after that, among these three ratios, we need to identify the smallest positive. So this is your pivotal row. So the intersection of pivotal column and pivotal row, that will be your pivotal element. What is the next step? So we need to make this 3 as 1. How can you make that 1? So let us divide the entire row by 3. So what happens? So 1 by 3, 1, 2 by 3, 1 by 3, 0, 0, 11 by 3. So look at the next table. So we got this, right? And later we have to make the other two elements in the pivotal column as 0. So we have to make this 2 as 0, and we have to make this 1 as 0. So in the new pivotal row, we have 1, right, at this place. So let us do the subtraction, and we have 2 here, and in the new pivotal row we have 1. So let us multiply throughout this row by 2, and let us do the subtraction, and after that we have the following. So these are the following thing. Again, repeat the same step. So look at the delta row. We have to identify the smallest negative number, and that is your pivotal column, and we have to consider the ratio of quantity by pivotal column element. So here it is 11 by 3 divided by 1 by 3, which is 11, 35 by 3 divided by 1 by 3, which is 35, 64 by 3 divided by 8 by 3, which is 8. So among these three numbers, which one is smallest negative? So 8 is smallest negative, so 8 is smallest positive, sorry. Among these three numbers, we need to identify the smallest positive number. So that is your pivotal row. So the intersection of these two is pivotal element. So here 8 by 3 is the pivotal element, and we need to replace this s3 by the corresponding variable x. And finally, what is the next step? We have to make this 8 by 3 as 1. How can we make this 1? So let us multiply the entire row by 3 by 8, so that it will be 1. And we have to make this 1 by 3, 1 by 3 and minus 1 as 0 by suitable row operation. So this is the thing we come across. So this is the thing we come across. So this is look at the delta row. All the entries are non-negative. So this is the optimum simplex table, and I can say that y equals to 1, x equal to 8, and here there is no z, so let us consider that as 0. So x equal to 8, y equals to 1 and z equal to 0, therefore the maximum value is 19.